Hello and welcome back to my channel. So today I wanted to look at a logarithm problem that I found on a Descartes contest. Those contests were like from a long time ago, so you probably won't find this question in too many places. But I wanted to show it because it really illustrates, the definition of logarithms, right? And the more you understand logs, the easier these kinds of problems will get. Right off the bat, you might see, if you do understand logarithms and you know log laws or logarithm rules, you will know that we can use change of base here because it looks like we have two different bases, right? But the reason they gave us this n value for the base is because we can use it somehow, right? So, so let's jump into it. And so there are two ways to solve it. There's the slow way and the fast way. I'll show the fast way first, and then take a look at what most people would do, which is the slow way. And the solution is pretty concise, right? And the more concise the solution is, the better it looks on contests, and the more marks you can get. So, we can jump into it. So, what does a logarithm output? It outputs an exponent, right? Because we're saying for any base n, we're putting an exponent on it. We'll call it k. It's going to output some value. You can say m. Logarithms are saying log base n of the value that we get is going to output our exponent k, right? So this log base n of 486 root 2 is saying that some exponent we put on n to get 486 root 2, right? And fortunately, this exponent that we put on n to get 486 root 2 is the same as the exponent that we put on 2n to get 1944. And usually when they give only two numerical values in contest questions, you might be able to find something to relate these two to, right? So you might notice that 486 times 4 is 1944, right? But we have this root 2, so we're saying 486 root 2. Instead of 4, it'll be times 2 root 2. Will get us to 1944. So that's just something to keep in mind. So now that we know that this is going to output an exponent, and this is going to output an exponent, let's just name that exponent some value, right? We said k. Let's just say this exponent is k, that we put on n to get this, and we put on 2n to get this, right? So now we can write two new equations. We said that n to the k is m. Well, in our case, n is just n. K is k. M is 486 root 2, so we can sub that in. N to the k is 486 root 2. That's our first equation. I believe proper notation is actually over here. And the second equation is this side of the equation, which is 2n quantity to the k. It's going to get us the 1944, right? And instead of doing change of base, which could work, but I'll show you later, it's much longer. Instead of doing change of base, this is much faster. By now you could probably see that we can do some substitution. So if we distribute this k, right, we're saying that 2 to the k times n to the k is 1944. This is still equation 2. Actually, we can just scratch this, right? So what do we see? Look at two equations. What's the same? What's different? N to the k equals 486 root 2, and 2 to the k times n to the k is 1944. So we can sub in this value for n to the k. So 2 to the k times 486 root 2 is what we subbed in for n to the k equals 1944. And we said that 2 root 2 is our quotient when we divide 1944 by 486 root 2. So 2 to the k, I'm writing way too big, 2 to the k equals 2 root 2, right? What do we do from here? Well, what's root 2? Root 2 is 2 to the 1/2, right? So we're saying 2 to the k equals 2 to the 1 times 2 to the 1/2. Same base. Let's just add the exponents. So 2 to the k is 2 to the 3/2. And just by comparison, we can see that the bases are the same. So exponents must be equal. So k is 3/2. And yeah, so I forgot to tell you what the question is asking. The question is asking for n to the 6. What is n to the 6? And yeah, so to find n to the 6 is pretty easy at this point. What we do is sub into one of these equations that k is 3/2. So let's sub it into equation 1. How do you scroll down this? I don't even know. Let's just keep going this way. Yeah, n to the 3/2 equals 486 root 2. This seems tough, right? What do we do from here to get n? Well, let's not go for n. Let's go for n to the 6, right? So we can actually multiply our exponent by some amount to get n to the 6, right? In this case, it's going to be 4, right? So let's put both sides of the equation to the 4. And then we get n to the 6 is this 486 root 2 to the 4, whatever that might be. Probably in the billions. But yeah. There we go. So that's how you solve it the fast way. And yeah, so let's move on to the slow way, which is the change of base.